Have you ever been to the ocean at night and seen a light display rivaling the stars? Or maybe you've seen the hauntingly beautiful photos of creatures from the deep sea. Or perhaps you've been out on a summer's night and seen the fireflies, like lanterns across the sky.
All of these are examples of bioluminescence.
Well, many people know bioluminescence through fireflies and the few other land-dwelling creatures that emit light. It is actually the most common in the ocean. Around 3/4 of macroscopic organisms in the ocean emit their own light, which makes it one of the most common ecological traits on Earth. Isn't that amazing?
You may have noticed that bioluminescent creatures often emit a bluish-green light. This is because that color has more energy. To be able to understand this, we have to be able to understand the properties of light waves in water. There are a lot of atoms for the light waves to be reflected off of, absorbed into, and finally transmitted through. Let's see this in action. As you can see, in the end, the light wave was a lot smaller. It lost energy. This would make it so that it couldn't go as far. As you may know, color is decided by the light wave's frequency. So green, for example, has a different frequency than red. And because they have different frequencies, they also have different wavelengths. Green has a shorter wavelength, and therefore has more energy to get through the atoms. Let's watch a green wave race a red wave. The green wave easily won. And so, even though there are multiple colors of bioluminescence, blue-green is the most common, so that the light can travel further in the water. So it's great that these organisms can bioluminesce, but how does it happen? Bioluminescence is a chemical reaction that occurs in the photophores, represented here by a beaker. A molecule called luciferin reacts with oxygen, absorbing the resulting energy and releasing it as a photon, or light waves. I will demonstrate this using luminol and hydrogen peroxide as the oxidizer. Let's see how it goes. So here is my luminol, or luciferin, combining it to start the oxidization process, and it's glowing. Let's turn the lights off. You can see it glow just like bioluminescence. Notice that this also emits a bluish light. There are many types of luciferin, and some organisms use catalysts to speed up the reaction. These catalysts are a luciferase or a photoprotein. A photoprotein is luciferin bundled with oxygen, so that when it's exposed to an ion, which is usually calcium, the reaction starts.